Hello and welcome to PTZOptics Visual Reasoning AI online course, Module 1. I could not be more excited to be part of the ProAv and broadcast industry as we start to adopt these modern AI workflows. This is an online course that's included with a book. This is the Visual Reasoning AI book that you can download for free. You can pick up a paperback copy on Amazon, and it includes an entire open source GitHub library with examples of AI for use with broadcast and ProAv that you can customize and change and contribute to. Could not be more excited. Let's jump in. So Module 1 in PTZOptics training session here is understanding how AI sees and explains live video. We're going to break this down today so that we can understand the fundamentals, and then we're going to jump into some really awesome examples and tools, such as allowing a PTZ camera to track any object, not just humans, but animals, basketballs, things of that nature. We are going to be jumping in to describing scenes and automating control systems, all with the power of AI. Now, I want to explain why this matters for ProAv. I've been in ProAv for over 15 years, and we're always looking to improve our control systems and our ability to automate things. And ProAv systems are becoming more AI automated and AI assisted. And cameras are evolving to become more intelligent. That means not just having AI computer vision chips on the cameras to do things like auto tracking, but actually being an input to the audiovisual system. So the visual data coming from cameras, the audio coming from microphones, it now can be used with AI, and understanding AI is becoming a core AV skill. And new tools are here today to help you automate your next AV system. We're going to be showing examples of that in our book and online course. So you're going to have the ability to get offline and just read the book in your own time in a paperback. I know I appreciate that opportunity to take an online course and get a certificate. You can play with our visual reasoning playground on GitHub. It's expansive. It's growing. We have people forking it and changing it and contributing to it. All of everything you're going to see from a code perspective is open source so that you can customize it and change it to your needs for your customers. And after you take this module, you're going to be able to explain what is visual reasoning. You're going to be able to describe how it's different from traditional computer vision that you may have seen, computer vision. And we're going to understand what a vision language model is. You may be familiar with an LLM, a large language model like ChatGPT. And we're going to break down what a vision language model is. In fact, ChatGPT and Claude and Gemini actually kind of combined a lot of this technology in the background so that you can have vision capabilities inside some of these really popular flagship LLMs. We're going to be able to interpret and use AI explanations for live video, which is kind of a foundation of building the automation. It's understanding how AI explains live video and how that process works. So what is visual reasoning? It's the ability to see and understand what you're seeing. And that for humans, that's easy, but for computers, it's something that's really emerging right now. And it's allowing us to distinguish between a singer in a dress versus someone with a guitar, and take the audio and the video and to create a fusion of information that we can use for automation in professional audiovisual. So this goes way beyond traditional computer vision, where we're just making detections and we're labeling things, but it adds context and relationships. So for example, who is the presenter? Who is the person speaking? Who is the person that's most engaged with the content? We can literally detect these people now because we have context from a vision learning model, and it doesn't require computer vision training. That was a huge barrier of entry to using visual reasoning, and now many of these tools are free, open source, and very low cost, so integrating them into our professional audiovisual projects have never been easier. So what is the visual reasoning playground? I'm going to jump right into this in a second here and show you what it can do, but we have currently about 10 plus visual reasoning tools. You can test them, you can learn from them, you can fork them, you can change them. And what you're going to see is lots of different use cases for understanding how AI sees the world so that we can build really reliable and intelligent AI workflows. And again, it's all open source, so you can use it for your projects. These are all custom built to be examples. So there's some really cool features that I'm going to jump in. Plus, I've included some fun Easter eggs. Now, let me take you to the visual reasoning playground real quick. So this is on GitHub. So if you go to, I'm going to just take you from the beginning here. If you go to github.com/streamgeeks, you will see the visual reasoning playground. And this has got all these different folders in here because it's all open source. And we've got the ability to describe a scene, do detection boxes. We're going to do gesture control of OBS, scoreboard extraction for sports, extracting data from scoreboards and using them in lower thirds, the ability to count things, which is used in manufacturing, AI color correction, PTZ cameras as a framing assistant, analyzing scenes, zone monitoring, which is popular in healthcare, where if a person falls out of a bed, we can monitor a specific zone. We have the ability to do smart photography, auto tracking any object with the PTZOptics MoonDream tracker. And basically all of this is available in the playground. And so what this is it's literally all of that code hosted on GitHub. So you can try it immediately. There's a little tutorial. I'm going to skip that right now. But one of the things you can do is you can use it with the videos that are included, which we'll do right now, but you can also use it with your own webcam. So you can select your own webcam as well, so that you can literally test it in your own environment with your own cameras. But really quickly, since we looked at the playground, you'll see we've got all these tools that you can jump in and out from. We're going to be doing this throughout the course. Let me just show you one quick demo of the scene describer for today. And you'll see that we have the MoonDream API key here. In fact, I think I am getting ahead of myself. So we are going to jump into this when we dig into the hands-on demo here. So this is what we're going to be playing with. It's really, really fun. On the left-hand side is a visual reasoning status bar, so you can see what the AI is doing. In the middle, you're often going to see the video that we're working with. And then below, you're going to see some of the actions we can take. For example, what's going on in this scene. Let's send that to the AI, and then we get a response. There's a man in a dark suit with a white hard hat passing stacks of gray concrete slabs. So we'll get into all of this in a moment, but I just wanted to quickly explain what the visual reasoning playground is and why it's so exciting, because it's fun. And there's Easter eggs in there. We're going to be improving this quite a bit over the course of this, over the visual reasoning launch. So here's the big picture here. AI is becoming the eyes and the ears of video production systems and audiovisual systems that are integrated. Basically, the video is visual data, and the AI can understand that data, and it can take actions. And audio is the same way. So audio has speech data, which is super valuable for us. Sometimes there's other audio data as well. The AI can understand it, and the system can act. So if we hear a speaker, we can determine what they're saying, get context, we can see who's presenting, we can see what's happening in a room, and we can automate the audiovisual system. And we're going to show some examples of that. This is going to give you an example. Again, there's a lot of high level in module 1 here. Essentially, if you have a video stream, you might not need to send every single frame of video to your VLM. That would be expensive and potentially not necessary. So what we're going to do, especially in this course, is we're going to take single frames, maybe 1 frame per second, maybe 1 frame per minute. It depends on your application. We're going to take that frame of information and we're going to send it to the AI, if you will, right? In this case, it's going to be MoonDream. And I'll introduce you to a really cool open source vision learning model, MoonDream. It's going to analyze images for us, and it's going to use visual understanding, and it's going to send back a description of what it sees. And the AI can understand an image. And because of that, we can now build systems around vision to trigger things based on keywords and based on what is actually being seen by the AI. So how is this different from computer vision? You may have seen computer vision before. It has the ability to detect things. It's also very efficient and very fast. And Visual reasoning, right, using a vision learning model doesn't necessarily replace computer vision in every case. So what computer vision does is it detects objects, it labels the pixels, and it outputs data. So you have to build a computer vision model in order to run that model. With visual reasoning, it understands the entire scene, it explains the meaning, and then outputs the context. It's much easier to work with from an online course perspective for us. They are different, and we will discuss their differences throughout this course. But I just want to make sure that that's understood that computer vision requires building computer vision models. It's a lengthy process. It requires creating and labeling tens of thousands of images. Whereas with visual reasoning, the AI has already been trained on all of that and it understands the context and the scene. And we can immediately get detections that are fairly accurate and explanations of what's going on, which is highly valuable for broadcast and ProAV. Now, why does ProAV need visual reasoning? Well, we have live environments that are constantly changing. It's near impossible to build a computer vision model for every single situation that we're going to be in ProAV and broadcast. And operators need explainable automation, right? We need to be able to discuss, and you'll see in this course, we're going to be able to talk to the AI and say, hey, camera A, go find me something interesting. Go find me someone who's having a good time. I need a B-roll shot for my live stream. And you can do that. You can say, go track the cat, go track the horse, go reframe this scene. You can actually give instructions and goals to the AI verbally, and that it creates trust and transparency in these live environments. So it's going to be really fun as we do all of this. Now, really quickly, I'm going to give you some high-level information. Again, don't worry. It's not going to be too crazy in this course. We're not going to be actually coding. We're actually going to be using agentic coding. So what we're using is vision learning models. We're going to use MoonDream. We're going to use audio models. And for that, we'll use OpenAI's Whisper. And we're going to use agentic coding tools. And for this course, we're going to use Cursor. But there are a lot of agentic coding tools. So what are all of these? Vision learning models, such as MoonDream, are out there. They interpret images. Now, they don't really interpret video. They interpret images, and they send back descriptions. And we'll look at the intricacies of that. Audio models, they interpret audio, whether it's live or recorded. They're going to give us a transcription. What is the AI hearing? So we're understanding what's the AI seeing, what is the AI hearing. We're going to have an agentic coder that's going to allow us to customize all of these inputs to do what we need for our ProAV world. And then with the release of this book and online course, we're also releasing a visual reasoning AI harness. And what this does is it allows us to build a context and infrastructure for professional AV and broadcast so that we give these models and agentic coders context about what we need, the things that we're trying to accomplish in ProAV. So in this case, we're going to have PTZOptics API known. We're going to be using vMix. We're going to be using OBS. We're going to be using Zoom. We're going to be using Extron and different known ProAV manufacturers and APIs. What the harness does is it allows us to create a context file that brings all of these kind of generic industry AI models and puts them in the context of the goals we're trying to achieve for ProAV and broadcast. It's really, really interesting stuff. There's a lot of data to support how it's transforming the way that we can use AI for our industry. This is like kind of a core learning for our module 1 is these vision language models, they can take a camera input. They can also take language. So you can explain exactly what it is that you're looking for in the scene. So if we're looking for a presenter to auto track, if we're looking for the person who's speaking, if we're hunting for information in a scene, in live streaming and production, sometimes you're looking for someone in the crowd that would be interesting to broadcast. You can request that from the vision language models, and what you get is a description and basically context to control a PTZ camera or to automate your AV system. And so it's really, really cool stuff. Very excited to play along with this with you guys. And wanted to make sure you guys understood that VisualReasoning.AI is kind of like the home base for our course today. And so VisualReasoning.AI will go ahead and pop over there. It includes an entire ecosystem of all of our partners that we're working with. And you can be one of our partners potentially. We can help promote projects that you're working on. Let's go to VisualReasoning.AI. And you could be here. So you can literally log in here. You can test visual reasoning for free. We make it very, very easy. We're creating different examples. Like as you can see here, you can see kind of the visual reasoning working in a conference room where we're automating, basically from a visual context saying, look, there's people in this room. We should start recording this meeting. Oh, this person is the presenter. Let's zoom into them. Let's switch cameras. Let's automate the audiovisual system. This is the type of thing that we're going to be going over in this course. And you're going to have all the tools to play with it and learn how it all works and customize it. So VisualReasoning.AI is a great space to learn a little bit more. This is where you can download the book. This is where you can get all the free tools. And it's just kind of the home base to learn a little bit more on your own time as well, exploring the APIs and all of the things that make visual reasoning so exciting. So the three technologies that I want you to know coming out of Module 1 is traditional computer vision, which is trained on objects, right? We train on these objects. It only sees what it's trained on. It doesn't have context, right? It's just looking for specific things that you've trained it on specifically, which is very valuable in manufacturing and different places where we need it to be perfect. Now, an LLM, which you probably have chatted with ChatGPT or Gemini or Claude, this understands and generates text, but it's not necessarily a VLM. If you ask a ChatGPT to describe an image, it can do that by calling a VLM, actually. It has a VLM working in the background. It's important to understand these foundational AI technologies as we start to build and customize them for our customers and clients. So the mental model here is that traditional AV is traditional computer vision is kind of a specialist. It might be just looking for a basketball, but it's not going to see the cat or the plants. An LLM is incredibly a genius, but it doesn't have any vision. It's just not built for that. But a VLM can then turn that into text and then kind of really complete the circle here where a VLM can kind of create descriptions and give those to LLMs. And that's what we're sort of seeing today in 2026 is these beautiful workflows of an LLM working with a VLM. And in some cases in this course, we will be using traditional computer vision and comparing it to using a VLM because traditional computer vision often runs faster and is better for certain things like auto tracking. So we will go into all of that. Now, at a high level, as we do each of these modules, we're going to be going over a ProAv pipeline. And it's very simple. It's a 5-step pipeline. What it's going to be doing is we're going to be starting with the media, right? Are we using a video clip? Are we using audio inputs? Are we using NDI? Is it a webcam? That's the input to the system. Then we're going to be applying perception, right? Are we drawing detection boxes? Are we detecting something? Are we looking for gestures? We're going to be using the VLM to perceive what's happening in the image. Then we're going to reason, okay? We're going to interpret the scene. And we can do that by, sometimes it's just an output. It's just, hey, this is what I see. And that can be done in JSON. And we're going to look at structured JSON outputs and automating a system on that. Then we're going to make decisions. And those decisions are going to have guardrails, okay? When a VLM sees something, there's a confidence level that it sees it at. And so based on, is it confident enough? Does it fit within our guardrails? We don't want to make too many decisions too quickly, so we'll have cooldowns. We'll go over all of that, but essentially, we're going to be controlling things, whether we're switching a scene in OBS, starting recording in vMix, controlling a PTZ camera, or just automating your production or AV system. That's the ultimate thing we're trying to do here. We're trying to control the AV system with AV. It's really, really cool. I've been doing this for a long time. Very, very excited about this. One thing that I want to make sure you come away with this course is understanding that where is the AI actually happening? This is a very important concept. Is it happening in the cloud, or is it happening locally on your local area network on your machine that you're running it on? Now, in the cloud, we use API keys, and we'll be discussing these quite a bit. They kind of work instantly. There is latency, though. But with a local model, you have to install it on your computer. You're running a graphics card, and it's more complex, but it's often open source, and sometimes it's even free. So local models have a lot of value, especially if you want to be HIPAA compliant, or if you want to be completely private. You can run that on your local computer. With the cloud model, data is leaving your network. It might be encrypted, might be secure, but it's leaving your network. And for the government and for healthcare, that is unacceptable, especially industrial manufacturing. So with local models, it all stays on premise, and that's incredibly important. With cloud models, we are going to have to pay for every API call. It might be 0.0001 cents of a penny, but if we're doing thousands of those every minute or so, it can be costly. And so there's a trade-off in ProAV, whether we're going to be deploying hardware or using the cloud. Now, when we use the cloud, we're working through a network. We're going through the public internet. We're coming back. And one of the things I included in the visual reasoning playground is latency reports and logs. So we can look at how long it's taking to send cloud calls. And this course is mainly going to be about the cloud. We're not going to run any models locally because that would be in a more advanced course. But we will be kind of making sure you understand the differences. And so for the visual reasoning playground, we're going to use 2 API keys, and we'll go into all of that soon. All right, here we go. What is an API key? So it's an application programming interface. It's your key that you keep secure. You don't share it with anyone. It identifies who you are to the service that you are calling, and it tracks your usage so that you can continue to pay for it. We're going to use 2 API keys in this course. The first one is from MoonDream, which offers a very generous free 5,000 API calls per day. I hope that continues throughout the life of MoonDream and all of our courses. We'll see what happens, but it's free right now. And it's going to be really valuable. OpenAI has a tool called Whisper. It's totally open source. So if you're ever going to deploy this, it's a couple gigabytes and it'll run directly locally on your computer. But we're going to use the cloud because it's just easier. That is not free. It's not going to cost you a lot of money, but it's not free. And so we'll have to talk about how to calculate all of these API charges. But I've been using MoonDream extensively, and it really hasn't been too much to use. So that's awesome. Now, MoonDream, we're going to be looking at and using quite a bit in this course. It's an open source vision language model, and it allows us to essentially not just send images and get responses, but get structured feedback back so we can build ProAV audio systems around it. It's lightweight. It's affordable. We're going to get 5,000 API calls for free, at least as of January 2026. It wouldn't surprise me if that somehow changed one day. But we can run it locally. It's open source, so we can run this locally and deploy systems that have zero cost to our customers and to ourselves, but we can build so much value with it. It's really exciting. Now, if you're new to AI coding, this could be huge for you. I'm not a coder, right? I am not a coder. I learned a little HTML as a kid, but agentic AI coding, what it allows you to do is use natural language to build projects, to build apps, to customize these ProAV systems. So we're going to use an agentic coding tool called Cursor, and we'll be downloading and installing that soon. And it's going to allow you to take the GitHub files that are included in this course, download them, customize them, change the colors, change the functionality. It might be a great starting point for your next project. So it helps you write, modify, and debug code. And it's incredible how good this has all become. You don't need to have a programming background to do this stuff. You just describe what you want in natural language, and Cursor and other tools out there will help you build it. There's some really great tools out there. They become more valuable, these agentic AI coding systems, when they have a harness. And what that harness is it's you literally outlining the goal of either your business, your industry, or your project. And it's all kind of important because the more that we can outline for the agentic AI coders of, hey, this is my business, these are my users, this is their technical level, this is essentially where this project is headed, it can start making choices that are in the context of ProAV and broadcast. And Anthropic has a peer-reviewed white paper saying that successful completions by AI agents can be improved by 80% with a harness, just an AI harness in general. We're going to create you the visual reasoning harness. You need no programming background at all. And together, you can start with the visual reasoning harness for ProAV and broadcast. Maybe you find a better way to do it and you can contribute to the GitHub project. And together, we can really create an incredible system for our industry. I wanted to take a moment. I know this is a really long module 1 already, but to talk a little bit about how do we process audio and video with AI. And this diagram helps us understand something that is really important for this course. It's called demuxing. Okay, to demux a live stream or recorded video is to separate the audio and video channels. And so we're going to have a video channel that we'll use for MoonDream, right, for processing the images and the video data. And then we'll have an audio channel that we'll use for Whisper. And then what we're going to do throughout this course is build what I call a fusion engine. We're going to analyze the audio, we're going to analyze the video, and we're going to use it together to make decisions and analysis that can automate our AV systems. So one of the things we're going to do is we're just going to run a query on a single image. And what I want you to do is I want you to download and set up Cursor on your computer. Okay? Once you've downloaded and set up Cursor, I want you to go to MoonDream.AI and get your API key, because you're going to need that throughout this course. And what you're going to do is you're going to download and set up the Visual Reasoning project via GitHub. This is going to be awesome. What you're going to do is you're just going to type into Cursor to say, hey, I'm ready to get started. Let's import the Visual Reasoning Playground, available at github.com/streamgeeks/visual-reasoning-playground. And it's literally going to download it for you. It's going to set it up for you, and then you're going to be able to run that locally. You're going to be able to ask the vision learning model, meaning you're going to be able to send an image from your computer directly to MoonDream, and you're going to say, hey, what do you see? Just describe this to me. And you're going to be able to receive the structured output. I'm going to kind of fast forward a little bit and assume that you have either downloaded the GitHub directly to your computer, or you're just maybe using the visual playground that's hosted here at streamgeeks.github.io. But essentially here, let's just get our first query going. So we did this earlier today. What's happening in the scene? Let's ask one more question. Let's say, which direction is the man walking? Just any question is fine. Click OK. It sends it. Now notice in the top left, we talked a little bit about this. We got an answer, but it was in 1400 milliseconds. So 1.4 seconds. That's a lot of time when we are trying to do something like, let's say, auto tracking. It's too slow for that. So we're going to need to run MoonDream locally or use a computer vision if we want to do, faster responses. But anyway, we get a response. The man is walking away from the camera. Okay, that's not super helpful. That's okay. That's what we're going to learn. Ask a few questions about the scene. And then what we're also going to do is we're going to detect something. Okay, is there a helmet? All right, detect now. Boom, there's the helmet. We've got a box that's on the helmet. And let's just do one more here. So we can add a detection. Let's just do person. All right, detect now. Now we got the person in there too. Let's turn the helmet off. Just got the person. So you can see you can choose things to draw boxes. This is going to be super important as we start to learn how all of this works moving forward. And then you can see the structured JSON output in the side here. So this is all data that we can use, like exactly where is the helmet, X and Y coordinates, things of that nature. Let's not worry about it too much because that will be, we're going to dig a lot into that throughout this course. So let's talk about the key takeaways here. We're going to learn a lot here, but vision learning models combine vision and language to describe what you want with no training needed like computer vision. There's a kind of a 5-stage pipeline that we're going to be following, from media to perception to reasoning to making a decision and then finally controlling something. We talked a little bit about cloud versus local, and start with cloud for learning. And then if we need to, we're going to go to the local for production when we roll these out to our customers. We talked about API keys. Keep those secret. Those are your credentials to get in. And we talked about using MoonDream and Cursor, which are your tools for building visual reasoning systems. So congratulations. I know that was a lot. Next, we're going to be looking at visual understanding and object tracking. Again, you can get the book. I think it's really worthwhile to read along. And we'll see you in the next course.